Hello students, this question is taken from test series 5 EE from the subject power system from the topic transmission and distribution, and it is of 2 marks and it is type of linked data question for the question number 52. Given question, a 500 meter long single phase AC distributor has a total impedance of 0.02 plus j 0.04 ohm, which is given. The length of the transmission line is given 500 meter long and given impedance value is 0.02 ohms, and it is spread from one end, that is 240 volts. It is loaded as follows: 150 amperes at unity power factor from 200 meter long, 100 amperes at 0.8 power factor from 300 meter long, 550 amperes at 0.6 power factor lagging, which is given. The voltage here is 240 volts, that is supply voltage. Feeding voltage is 240 volts. Assume this is A option, feeding point A and B, and the feeding point B, this is the feeding point C and the feeding point D. From feeding point A to B, the current flowing through this transmission line is I1 plus I2 plus I3. From feeding point B, the current flowing through the C is I2 plus I3, and the current flowing through C and D feeding point is, that is I3. Where in the B feeding point, the current I1 is draws 50 amperes at unity power factor, where at the feeding point C, the value of current, that is I2, is 100 ampere at 0.8 power factor. At the far end of the feeding point, the value of current I3, that is equal to 50 ampere at 0.6 power factor lagging. These are the given condition, and given the impedance value of 0.02 plus j 0.04 ohm for 500 transmission line. We have to find the value of, calculate total voltage drop. So we have to find the value of voltage drop across the feeding point. In order to find the value of voltage drop, first we will calculate the value of impedance for the 500 meters, that is ZAB from A to B. The value of impedance is nothing but given from A to B, the distance will be 200 meters, where from B to C the given distance is 100 meter. That is nothing but from feeding point to C, the distance is 300 meters, which is nothing but 200 plus 100 is 300 meters, and remaining the given the complete length is 500 meters. So 500 minus 300, which is nothing but 200 meters. So from C to D the distance is 200 meters. So for ZAB, that is impedance between A and B, which is nothing but distance is 200 meters divided by total distance is 500 meters, which will get the value of 0.008 plus j 0.016. So calculate the same thing for impedance BC. For B to C, the distance between from B to C is 100. So the total distance is 500 meters. Total length is 500 meters. Calculate this, will get the value of ZBC as 0.04 plus j 0.008. Calculate the ZCD value like this, given impedance of this one, and from C to D the distance is 200, so the total length is 500. Then we'll get the value of 0.08 plus j 0.016. So I know the value of ZAB, ZBC and ZCD, and the value of I1, I2 and I3. So the current flowing through this is I1 plus I2 plus I3, and BC is I2 plus I3, ICD is I3, which is nothing but 50 ampere at 0.6 power factor lagging. So in order to find the value of voltage drop, that is nothing but current into the impedance. This is the formula to calculate the voltage drop, that is IAB total voltage drop is nothing but IAB into ZAB plus IBC into ZBC plus ICD into ZCD. So we know the value of IAB, which is nothing but I1 plus I2 plus I3. IBC is I2 plus I3. ICD is I3. Same thing for ZAB, we have already calculated the value of ZAB, ZBC and ZCD. Substitute the values of this in the formula, we'll get the value of 5.546 volts, which is nothing a voltage drop across the feeding point is nothing but 5.4546, which is option A. Option A. In this session, we have studied about how to calculate the voltage drop for the given transmission line and how to calculate the impedance for the given length. Thank you.